Welcome to my talk on how I taught my 10-year-old brother to love Python and programming in general. So everyone here is probably aware that we need to learn to program for the future. I mean, those are job applications for programmers, demand. Here's changes in skill requests. Here's for STEM jobs. Here's a % change in employment for computer occupations. So obviously, as we advance in technology, everything's going to have computer chips in it and servos, motors, and they're going to need to be programmed by somebody. And there's not enough programmers right now, so we need kids to really step up and do this stuff. So it's also not just the future; it's right now. There's kids who are building iPhone apps, who are building websites, and doing these things. The same effects that have helped other entrepreneurs, such as like the scalings of costs, Amazon Web Services, cloud services, make it so anybody can launch something, as well as like proliferation of tutorials and other things like that, have really kind of set in motion the possibilities that a not just super technical kid can get programming, but almost anybody can. So while the programming itself is actually not really the hard part with the kid, it's actually their attention span. So a lot of times they're working, they're in school, and they really just don't want to learn more. Like if it feels like learning, not going to happen. So they don't want homework. If it feels like that, they're done. So really the key, another thing here to understand that's different about this generation is that technology, using and loving technology in terms of playing on their phone, does not equate to wanting to know how it works or build the programs themselves. So that's kind of different from my generation and even the generations before me, is that I had to tinker. I had to take out the pieces of my hardware when they broke and figure them out. Here, these type of hardware that's out today, you can't even repair it, a lot of them. So we kind of need to figure out a way to get kids involved. And so looking for a solution, I ended up coming across what's called Scratch and Lego NXT MINDSTORMS. So these things both share in common that they have a visual programming language I'm going to go into in a second, and also that you can make happen. So the Scratch was created in 2006 by MIT. Is visual programming. So choose what you want. Without really knowing the actual, like having to type the code. Like typing is actually a problem for kids. They're really slow and it's really frustrating for them. So the visual programming languages are very helpful because they just need to know loops, if-then statements, things like that that are the basic foundation for programming. If you can get these concepts in their head, they can start to see the world differently, where they start to see those actual things. So I was very proud of this. This is the first time we got the NXT, got it for his birthday / holidays, and this is him sitting down, literally like just working himself, and I just had gone away and come back, and he was using this visual programming language on my show in a couple slides. So this was really exciting for me because I was like, I begged my parents to get in this thing. The NXT is a little around $300 or a little more. And so I didn't wait for him to get it. Finally got it, and he was excited about it, because he loved Legos. The idea is like if a kid loves Legos, they'll love this thing. So the Lego comes with a bunch of inputs, like a rangefinder, infrared signal. It has motors. It has these bump sensors, which you're going to see us use in a second. This is the brain, this controller block here. So the brain is really like the device you can just plug in by the wires and stuff. So here's just what the visual programming language looks like. This is a looped system, basically saying like go forward, turn right, go forward, turn left, go forward, turn around. So like you could make an autonomous bot basically just saying go forward until you pull in the sensors, like until the infrared sensor senses a wall, and then if it senses a wall, back up, turn 20 degrees, and continue going forward. So just building that with 2 or 3 instructions makes an autonomous robot. And when a kid can see that and literally will drive around the entire place, I wish I had it for demo here to show you, like it would just run around and never hit anything. And that really is like kind of a... So I told my brother, doing this presentation, he's only, he was 10 when we started, and now he's 11. He's doing all these kind of things, and the books, some resources I could recommend, has has like step by step how to go through and do it. So I said, can you make something for me? I didn't give him no parameters, and this is what he came up with.
So how it starts is I'm going to hit a golf ball out of a push sensor, which is set. The push sensor is activated. The arm, the robot arm here motor, is going to spin the milk duds container to a color sensor, which has been set to the color yellow. So once it sees yellow, it has a very short radius by the width of the golf club with. So that milk dud is going to be right in front of it, sensing it. And then this thing, once that is sensed, it's going to knock down a little arm. You're going to knock down the lighter that set up a little bit down, more real down now. You knock down the lighter.
So I didn't teach him what a Rube Goldberg is. He, knows, and this is like what his brain, and it's really neat. You can start to hear his language in there, that he has got these concepts. He knows when he's programming it, like this is going to wait until this goes. This is going to wait to see this, and he kind of has figured out all the way that things work. Like this is pretty innovative use of a motor. We never really did anything like that when I was working with him. So, I mean, he's learning a lot, but apparently I still need to teach my mom. She sent me that vertical video. I had to yell at her, if I taught you nothing. It's pretty stressful getting all those videos. That's how many vertical ones she sent me, and I had to have her redo all of them. So I did get that one. I did get one that's a slow motion operation. So that was this push sensor here being hit by the ball, which swings this motor arm that brings the yellow box to the color sensor, which then tells this motor arm to spin 90 degrees to knock down these Legos. So let's just sum up the NXT stuff. I highly recommend it. If they like Legos, they will like NXT hands down. It's really like what you imagine with the kid's imagination, where you're building something and then it moves or it comes to life. You don't actually have to use your imagination. You can do the real thing. And it's really neat that this exists, because when I was a kid, it was mostly just imagination, and we didn't have as many parts, and there's really it's really neat, and kids these days are really lucky to grow up with so many awesome little things like that. It's very simple. This is a book this is a newer version of NXT that's come out since I was working with him and we bought ours, but it basically teaches you how to build them and then how to code them, and it slowly adds in the functions. It teaches you how to use the sensor, and it's really easy, and I think most kids could pick it up in a couple of days, or if not hours. So it's a great introduction to programming concepts, is what we're really trying to get into their head here, so that we can move on to advanced stuff. So as a Python programmer myself, it's my favorite language. I really wanted to figure out how I could get him into it. He can't type fast again, so he's really not interested in writing huge, long programs. And also, what kind of program does a kid want to make? He doesn't, what's he going to do? People ask me, what do I build when I program? I'm like, oh, I build a scrapers, I built a website. And it's like, kid has no desire to do that. So the real key here is also finding what the kids love and what they can do and how we can get them involved in it. So what do they love? I think kids, we know, love games. So this is not my brother, but this is a real situation that I have heard from multiple parents occurs, and I've seen online other pictures. Basically, kids, when the parents will make them go outside, and they'll actually just go on their computers, or they'll go on their devices and just sit there in the just in the shade on them. And it's kind of a neat, funny concept. I've found it happening to myself before. I've blogged about where literally I'm in the living room and I'm on an iPad, my roommate's on an iPad, his friend's on an iPad, all just quiet, sitting there looking at our devices. It's a very strange and interesting world we live in. But so these kids love games. So part of this, I said, let's try maybe to make some games, because everybody loves a game, and it has some function, and they're also fun to share with friends. The learning is kind of subtle and incremental, and so the concept. So this book here is a great book. I think it's available free online, but if not, it's definitely around. So basically, it starts with the basic Python programming concepts. And it kind of slowly integrates. First, we'll start with a storytelling app, and then a joke app, and a few other kinds of basic ones, where it's really neat because I'll make it, and I'm like, okay, let's move on. He's like, wait, I want to make it say this. Can I do that? And that's the really neat things about the kids, is they're just understanding that, hey, I can be in control. I can determine what this says. So it's not just in there. I can make this joke. What about this joke? And I'm like, okay, enough jokes. Let's move on. And it's that's kind of a good thing when I'm, the one saying let's stop and go on, and he wants to keep going. So when you kind of hit that level, you're right. You're on the right path. And I also want to make a note is that as a kid, when I was in middle school, which are the lost years everyone knows of your adolescence, I spent a lot of time playing games, like hundreds of hours. I was in tournaments. I would go to LAN parties. I was playing games, and you know, maybe I like increased my reaction speeds and things, but otherwise, like nothing of value was gained from playing those games, aside from like the social stuff, whatever. But I think I wish I had, now looking back, all the work I had to do to learn programming later on, I wish I'd been making games or coding or learning to code instead of just playing someone else's thing. And as an entrepreneur, I also am always on the side where I'm building things for people to use. I'm building services for people to pay me. You want to be a creator and not just a user and not just like a sheep. So I think that giving people the ability to create things really allows them to transition from user to creator and doer. So, here's him. This is one of the games in that book. It's a hangman.
At the beginning, it asks you, would you like to the category, and I go A-N-I-M-A-O-S. I have to spell there, because otherwise it's going to kind of glitch, like a lot of games do. And it's a 4-letter word, and I don't know what it is, so I'm going to start guessing vowels. So A, E, I, O. Okay, so it's not O. It could be anything from this giant list in the top yellow. Giant list. So I have no clue what it is. It picks it pretty randomly. I'm just going to go over here and see. It's going to be S. P. No. See, every time I type in this letter, this thing grows a little bit, like a hangman. And I go G, and just grew a letter. And I go R, and this is how it goes. See, you'll run out of guesses. After 6 missed guesses and 1 correct guess, the word was wolf. Do you want to play again, yes or no? You just have to type Y or N, or any word or anything that starts with Y. So go yeah, and it'll restart it as animals again. You have to end the program to pick a new category. And that's the video game over there that I made.
So, see here, he's getting the hang of it. A little bit bad fun there. Basically, I mean, you could see here, like, just a little thing at the end where he's saying you could just put Y and you don't actually have to put yes, anything that starts with Y. That's like the way we had you don't actually need to say yes. Those are kind of things he liked. You can see, like, I helped him write it, and you know, most of these programming books you can they have online where you can like bring in the code, but we definitely modified it. And he would be asking for things like when the way the letters came in, how it always shows a fresh board. Before in the program it just would show the old one on top, and it didn't really flash in the new ones like that. And he was very adamant about making it look clean like that and having so. You know, he's asking me, how do we, you know, do that? And I say, I don't know. I mean, I may have had a clue, but I'm trying to teach him the real thing about what I've learned about going from a novice to like a programmer and learning is that even the experts are constantly Googling, constantly searching, and constantly, like, the smarter you are, the quicker you go to Google. You like won't even waste your time, right? Because you know what you need to do to first. There's actually a paper I found on it, which is like how do programmers answer. And there's actually a couple other good articles that I came across. Like, am I a good programmer or am I just good at Googling? Like, people actually doubting themselves on their abilities because they're so quick to go find that. But we know programming and Python, like if something's been done before, do not do it again. Do not reinvent the wheel. So the idea is that I've tried to teach him how to understand what he doesn't know, and so he can understand the scope of what he's supposed to know. And then I explained to him that, you know, people like me and other programmers, we Google everything. And then I told him, try it first, break it. If it doesn't work, like then call me. You know, otherwise I'm getting calls on Skype all the time, which I'm happy to receive, but sometimes it's like try it. I would sometimes send him the let me Google that for you video. As an animation of like loading up the search term, just to kind of get that in there. So I'm trying to teach him how to be independent. He's been making other things. He's going through the books, and so you know, in the entrepreneurship world and in the development world, with an idea, people tell you solve a problem you have, solve a real problem. Are you sure your startup is solving a problem? Like, why do startups need to solve real problems? You know, Paul Graham, saying solve things for yourself. Like, don't just do ideas. So you see this all over, and so it's like, what kind of problems does a 10-year-old have, right? They kind of have, you think they kind of have it easy. Turns out 10-year-olds have actual problems, math problems. Like that is what they deal with every day, are worksheets like this that are endless and endless. And I will try not to save most of my diatribe against the, the academic institutions of elementary school and middle school that I've seen that are pretty pathetic in how many worksheets they give out and how little actual teaching is done and how much busy work that's really annoying. So I'd be calling him and I'd say, hey, what do we try to meet up, talk at least twice a week and do some programming stuff. So I would basically say, hey, like, what are you doing? He's like, I can't today. I'm so busy. I go, you're 10 years old. Like, I know how busy I live in the busiest city in the world. Like, I'm making time. You're going to make time. And so when I found out he had these problems, he said, this is just so repetitive. I know how to do this. So I'm not trying to help him cheat, but he's explaining it's repetitive. It's outdated. And, here's like the Model T line here. This is showing all these men doing the same thing. Here's Tesla's automotive line here. All robots. No humans over here. They have humans at the end, though. So, but, I'm trying to explain that to him, like, these are the kind of things that you should be using programs for. That's where they shine, is doing repetitive, automated things that, like, you've solved once, and now you can codify into an actual math problem. So, that kind of thing is really important for the kids to learn where to apply themselves and where to do that. So, this brought us to making our next program, which is his first real non-book generated one and kind of customized one. So we made a function solver that can do all the operations. We started with a GUI, with a line, command line based prompt that was pretty simple. It said, what's your first fraction, what's your second fraction, and then said, what do you want to do? And so he liked that a lot, and you'll see in this video. But he started telling his friends, oh, I got this thing, and he's like, well, how do I, like they don't know how to type it, they don't have Python, they don't, how do I get it to them? And so, and people, he was like bragging, it's really neat that he's so proud of his program and like people are actually like want this from him. So instead of being like nerdy and like outcast, he's actually like, because, in this regard, he was like, people were coming to him like, hey, I hear you got a fraction solver, like, like trying to come in there. So we eventually like modified it up a little bit.
And I'm going to show you a program that I developed. It's a fraction program, and how it starts is it asks me, what is your first fraction? I'll put 1/2. You go everything from simple numbers to really complex numbers. Hit enter. I hit second fraction. I'll put 19 hundredths. And it can add that, and then I go and I'll put multiply, or I'll put add. And I hit add, and it gives me 6900. And then I decided that this was too slow. My brother and I invented another type, another version, in which it uses a real interface and allows me to actually use clicking versus typing like a real calculator. And I go, I want to add, I'll do it again. My first fraction this time can be 12/20. And I hit OK, and then I hit 21. And then I hit 300. Then I hit OK, and it gives me my precise answer, as simple as possible. And then I hit cool, and it asks me what I would.
So you can see there, he added, I let him choose all the things on the button, and when you have a 10-year-old programming, they use buttons like cool. And so there's a lot of unique and interesting patterns that they do and little details that I never really thought twice about that he found super amusing or really fun, which I was like, okay, I just put okay or, to go on. And so, this kind of thing and solving a real world problem here is like how I got to this talk here today, because I posted this. I'm active on Reddit and in the LearnPython subreddit, which I highly recommend. For learning resources and other stuff, there's also a regular Python subreddit. That's reddit.com/r/learnpython. So I posted this on here, got some good feedback. I got my code critiqued pretty hard. I was like, I wrote this like, on TeamViewer with him. So, I appreciate the feedback. So, this is really like a pretty exciting time in terms of like getting him to be happy and excited about programming. He's actually like bragging about it, and he's showing people, and really he sees that I can make utility and I can actually solve my own problems. And obviously in this case, so that was a pretty good step for him. And I think that like these are the kind of things we need to think about as adults who can teach kids and have access to them. And I'm going to go into that in a little bit more in a second. So what's next for us? So we've kind of mastered some of the basic things there in some of those programs. So he's really interested in drones. I got him a microcopter recently to learn, get in that piloting. You can buy one for $30 on Amazon. So he knows how to pilot now. He's really into 3D printing, and I think that he's going to get a printer for his holidays this year. But I don't want him just creating printer stuff, and I want him to do more with that. So I think we're going to 3D print a multi-copter here. So you obviously buy the controllers and the motors and other parts, but you can 3D print the arms and the propellers and a number of other things. So it's really trying to bring together these technologies. And it's also fun for me, frankly. Like, I really don't have a 3D printer. And so, I really have I've used them and I've been around them, but I've never really had to like troubleshoot them and really had my own to run. So, by helping him, I'm learning myself as well. And like, I had never used the Easy GUI, the thing I used to make the math. And so I learned that myself. And people on the subreddit are like, how'd you learn that? Like, where did you find that? And I sent them the tutorials and things. So we're looking at that. We're looking at like Raspberry Pi, Arduino things. There's a site called Adafruit that sells kits. This is one of their kits with a Raspberry Pi and a touch-sensitive thing. And you write the code, you upload it, and it will be a touch-sensitive thing. So we're looking at some of these little projects that you could do. You can hold it in your hand and see, look at these lights, look at these things, look at what I'm controlling, and look what I'm doing. And then for some reason I showed him this thing, Jasper, which was a open source like personal assistant. It's an always-on microphone where you say, Jasper, tweet this, Jasper, search this. And he seemed obsessed with it. He was visiting me for 2 days. When I told him about it, he's like, can we like go, instead of seeing the city, he wanted to like sit in my apartment and hack on Jasper. So like that was like, I was like, you're the best city in the world, like let's go do something. And he's like, no, I want to like do this. I was kind of excited about that. I literally had to be like, I think our time's better spent, because I was having some trouble getting it loaded, like flashing it and everything. Like, let's just do this later. But that was really good that I had to like pull him away. So I'm running out of time here. This is the last 2 slides. So basically, what's missing? I've learned here that the schools are lacking. There's really no options. Like he goes to public school in Miami, and there's really not a lot of options for him to do. I said, where's it at school? Is there after-school programs? We found an after-school program. They went to apply to it, and it turned out they canceled it because not enough kids signed up. So even where the schools are trying to do these things and institutions, like if we don't have parental guidance and interest spurring kids into the programming field and into like doing this as an actual like thing, then we're gonna fall short like that a lot. And I can tell you, I use programming skills a lot more than I use free throw shooting. Like, I was a good basketball player when I was a kid. I practiced 2-3 times a week after school, and like it really got me nothing. I'm not gonna be an NBA player. I'm not gonna like, sorry, like I gave up on the dream. I know, like, same thing with soccer and tennis and all these other things that I was being carted around to do. They are no longer like that important. And whereas I use programming almost every day, like every day. And if not directly writing, using other people's programs and troubleshooting those. So I think that we need to like have a societal kind of shift and say, what is actually more important for you? Like, I understand the socializing, exercise. I'm very pro exercise, but at some point, the kid is going to get more value an hour spent programming than an hour doing suicide runs or shooting free throws and whatever. And programming can be social. So it doesn't have to be you sitting alone in a dark room drinking Mountain Dew or something. Like it could really, that stereotype is gone. And that's kind of what I want to help squash and kill and make sure that we are showing kids that there's real things, fun things, and you can actually be cool and do cool things with programming. And that's kind of the last point there, which is like, we need to make code not just fun and not just cool, but like useful for them. And I think that we can do that by kind of showing them things that they can utilize to improve their life with programming. So that's the end of my talk. I want to say thank you to Ethan. Without him, there wouldn't be this talk. My mom for filming and the patience, and she has now learned no more vertical videos. So it's one less vertical video creator out there. So we're doing, that's, if anything, we've done that. So my dad as well supporting it. My dad personally like got me into technology. I remember being like 7, 8 years old and having like the 32 megahertz computer, Packard there. We had to dial up onto the internet, a 28K modem, and fighting over with my brothers and sisters. And without my dad being an early adopter and pushing technology onto me, like I would not be here today doing this. I would be in some boring job in finance, like killing myself, like where I actually like love what I do, and I wake up every day excited to like get on the computer and literally like that's my favorite thing to do. That is the end of my talk. If you have any, I'm going to tweet out some resources. I don't know where that went. I'm going to tweet out some resources at Matzner. If you want to follow me now, I'll send out links to a page with all like the recommended books, everything I talked about here. And as well as like some other books that I have also used and that are available, and some other projects and tools like circuit board kits that are available on Amazon. There's a lot of really good toys on Amazon. If you go through there, they have like solar powered robots. Like I just buy him these like $20, $30 things. Like just send them every few weeks or month just to keep him like interested in doing new things. Magnets, like just anything that like that will spur interest in the technology and the physical side of it, as well as the technological. All right, that's the end of my talk. Questions?
Tell me how you transition from, I guess you had XT, had Scratch, but then how did you transition to the whole like command line and actually using like what? I guess most of
yeah. So there's 2 books. So I used that programming, the game one, the learning. Learning this one, Make Game, the Invent Your Own Python games. I found this one really good because it really doesn't try to teach you anything outside of like it. It's just like does this, and it's like, well, if you want to change that, you need to learn what a dictionary is. If you want to do this, you need to kind of learn a loop. So it kind of like slowly goes up, and it will help with that. So that was a really easy one to go because it's in that game mindset. So I was like, instead of saying you want to program, I said you want to make some games. You want to play a game.
This isn't meant for kids. It's for beginners.
It's generally kind of meant for kids. I mean, if you read these things, they're like kind of silly, some of them in the beginning. They get very sophisticated in maybe 1,000-line programs as you go through. But really, I think it's not about him typing it out, because you could see he's a terrible typer, which I'm working on. But I didn't learn to type. First, I type 160 words a minute now. But I didn't learn to type until I was in middle school. So he was kind of always saying, well, you didn't learn to type until you're in middle school. So now he's in middle school, so I'm going to make him learn to type. But, one battle at a time, right? So basically, using that, there's another book called How to Think Like a Computer Scientist, which is it's a free book online. It really teaches computer science using Python, very basic with the concepts, and you can kind of get them in there. I started with simple things like A equals 9, B equals 10, A plus B equals 19, like showing this is a calculator, this is that kind of thing. You can ask me after. Any other questions? Oh, all right, I think I'm out of time. Okay, thank you.